You are tuned into People Tech Maritime's webinar, What Maritime Agentic AI Systems Might Look Like. Our guest speakers today are Professor Antorweep Chakravorty from the Department of Electrical Engineering and Computer Science in University of Stavanger, and Dimitris Lyras, Director of Paralos, Maritime and Ulysses Systems. Leave any questions you may have for them in the Q&A section for answering after the presentation. Here's our Director, Carl Jeffrey, to start the talk.
Hello, everyone. So welcome to our webinar about what agentic AI systems in maritime might look like. So we're joined today by Professor Antorweep Chakravorty from the Department of Computer Science of the University of Stavanger in Norway. He's a specialist in agentic systems. He does research on using different types of AI in energy, health, and smart cities. Antorweep is chair of the steering committee of the International Conference on Frontiers of Artificial Intelligence, Ethics and Multidisciplinary Applications, or FAEMA. And I'm also joined today by Dimitris Lyras. He has a family ship-owning background as director of shipping company Paralos Maritime. He founded Ulysses Systems in 1998. That's a special maritime software company with a focus on supporting decision-making. So he's one of the few people in shipping, maybe the only one with a long background in both ship owning and software. So first today, I'm going to give a 10-minute talk about what I think the future of maritime agentic systems might look like, based on what we've heard in our events and interviews. And then we'll have two deeper dives. First, Antorweep will talk about using agentic systems to integrate data silos together for about 10 minutes. And then Dimitris will talk about using agentic systems to support people's situation awareness in ship operations, showing useful things they might want to act on for about 10 minutes. Then we should have plenty of time for your questions, or maybe Dimitris and Antorweep would like to discuss each other's ideas. You can put your questions in the Q&A box at any time. Please say who the question is for. So I'll invite Dimitris and Antorweep if you want to turn your cameras off now, and I'll explain my model of what the future maritime agentic system might look like based on what we heard in our events this spring. So first, why are we talking about agentic AI? Well, one reason we're talking about it is it's a topic with an enormous buzz around it. And the second reason, maybe more interesting for maritime people, is because it can perhaps solve some of the biggest maritime digital technology problems which people already recognize, and also help us improve our companies in new ways. But that's not for the same reasons as the buzz. The reason for the buzz is that a lot of people have convinced themselves that agentic AI tools can replace people. That's probably why the US AI companies have such big valuations. You see quotes like 36% of IT leaders believe AI agents will replace many of their workers in the next 2 to 4 years. There's people saying that future managers will be managers of agents as well as people, and they'll call the agents digital workers. Now, since we're People Tech Maritime, we take a people-first approach to technology because we think that's what the maritime industry needs. So we're not getting into discussions about technology replacing people today. But on the other hand, agentic tools may help solve some of the biggest maritime digital technology problems, such as the difficulty integrating systems together, the complexity of learning new software, and that people often need to input the same data into multiple systems. And agentic tools may enable software to give us things we haven't had before, such as more in-depth warning about things we're doing which might lead to problems. So that can also lead to improvements in safety, environmental performance, and operational efficiency. We should define first what an agent is. So the simplest definition is a tool to do something which normally has a language model inside it. Some people say an agent is nothing more than a language model and a prompt. So here's my model of the future of agentic systems. I think the heavy lifting of maritime digital applications will continue to be done with the structured applications we have today. They've got industry processes embedded in them. They follow fixed logic, not probabilities, such as our processes for chartering, maintenance, procurement, emissions management, work coordination, and safety. We use these tools to support our work in chartering ships, crewing them and loading them, getting vessels out of and into ports, completing our voyages, complying with regulation and minimizing emissions. So I think companies will largely want to stick with the software they're already using because changing provider is a real pain. But we may use small and medium language model-based agents to fill in the gaps between these structured applications or provide the interface. And maybe these agents will be provided by the same maritime software companies. So I thought of a sponge cake analogy for the future digital environment. I don't know if you have sponge cakes where you are, but it's got a sponge body, it's got a layer of filling in the middle, and it's got icing on the top. So in my analogy, the structured software we have now is the body of the cake or the sponge, and the agents are the filling and the icing, connecting it together and sitting on the top as the interface. So first on data integration, so that's the filling in the cake. So we're hearing a lot about this. Shipping companies expect their various software tools to talk to each other much better than they actually do. Connecting two pieces of software together is normally done with painstaking work by a consultant trying to match fields in one software database with fields in the other. So in future, we could do this with language models. If a language model can read a web page, it can read structured software. If it can answer a question from text in written material, it should be able to answer a question with information from the software's user interface. So we can have an agent which can ask someone else's software what's going on that I need to know about, like what might delay my vessel getting out of the port on time. These agents could spot relations in data in the software and ask us if they may be relevant. So Antorweep is going to talk about that. That's the filling in the cake in my analogy. Now, for agents to support people's understanding, digital tools could do a lot more than they do right now. We've all had situations where we made a mistake, perhaps a costly one, and thought surely there was information in the software that could have alerted us about it, but it didn't. So my own example, once I bought a train ticket from London to Aberdeen, which is 7 hours. I was planning to come back the next day, but I bought the return train ticket on the same day by mistake. The booking software should have known I couldn't be on a train going to Aberdeen and a train coming from Aberdeen at the same time, but it didn't. So there's many more complex maritime examples of things the software could have told us and prevented a problem. So an agent based on a language model could help us find the right information at the right time from company manuals and company systems and emails. And I think Dimitris Lyras is going to talk about that. Something else agents can do is make the user interface to software much easier. So we're talking to software via natural language chat rather than through the interface. That saves us from having to learn complex software. We also hear crew having to type the same data into multiple software tools, such as performance data. So with an agent managing the interface, maybe we only need to enter the data once. So these parts are the icing on the cake with my analogy. We're probably talking today mainly about small language models, not large language models. Small language models are free open source software. You control them. You can put confidential data in them. You control where the data goes. You can train them to do what you want in your domain. You just need someone with the expertise to set it up. Or maybe you'll buy a ready set up small language model from your software provider. Large language models like the kind from OpenAI and Anthropic don't need any software expertise to set up, but they can get very expensive. You've got no control. They've got more capability, but it comes at a cost. So small models may be the way to go forward. So some closing thoughts. Please be kind to your existing providers of structured software. There's a lot of domain expertise and care which goes into building these products, and we don't think you'll be able to just replace them all with large language model tools if you wanted to. Large language models could get much more expensive. You don't want to get too dependent on them. They may have enormous capability, but even if this capability is helpful some of the time, it's going to have its limits based on the limits of what it's trained on, and you may get into problems if you rely on it too much, including that staff lose the capability to work things out for themselves. So instead, wait for specialist maritime agentic tools, perhaps from your existing software provider, which do what you want and are under your control. So that's the end of my part. I'd now like to invite Professor Antorweep Chakravorty from the University of Stavanger to explain how we can use agentic AI systems to connect data silos in the maritime industry. And I'll
I think you did a very good intro to my talk, and I will pick up from where you left off. So, briefly, I'm at the University of Stavanger. Stavanger is at the west coast of Norway. And in this session, I will be talking about the new developments in artificial intelligence, including large language models. What do they mean? Small language models, and how this agentic systems comes about. And I would suggest the or I will propose a conceptual idea on how these tools, new developments can be used to address one of the major challenges of any industry, which is bridging data silos, and which is relevant for the maritime industry as well. So let's begin if we move to the next slide. Uh, so if we look at the typical maritime sector, you have many subsystems, softwares, tools, databases, and so forth. Some of these tools are provided by the same vendor within the same ERP. Others are provided by different vendors. Some of them do talk to each other. Others, you need to create manual bridges and connectors between themselves. So it's a fragmented reality. Information lies in multiple silos, multiple subsystems. And when we talk about bridging the data silos, it's not sufficient to bridge the data silos because these data silos are within proprietary systems. So we need to also integrate the systems and subsystems as well. That includes the databases within themselves. So this fragmented reality, if we move to the next slide, leads to three major issues that I think are relevant for the industry. The first being rising cost. So whenever there is a new update to an existing system, one of your integration pipeline may break. Whenever there is a new requirement and you introduce a new system, you have to create a new integration pipeline with this particular new system or new database. That leads to integration issues. We are creating a large web of connections, and any one of those connections may fail, leading to further increase in cost, consultation, and others. Second is because we have so many systems and subsystems, these leads to multiple screens, multiple form of accessing these systems through logins, various dashboards. Crew and staff needs to reconcile information from multiple systems, and that could lead to workflow friction. And finally, when we are making decision on data, we usually would like to make decisions on the complete picture. But because of the very nature of these systems and subsystems being fragmented, often decisions are made on incomplete pictures. If we go to the next slide. So, and that's where traditional integration has its limits. If systems are provided by the same vendor, often we can trust those integration to an extent. But if you have your document management system, you have your reporting system, SharePoint, emails, and others, and you have to manually create integration within these subsystems and then have an overview of our integrated operations, it is difficult. It requires a lot of manual work. And this is something where we think AI and agentic systems can solve, reducing the manual repetitive work that follows a particular pattern and workflow. If we move to the next slide. So one of these new technologies in AI is your large language model. We have been using it via ChatGPT, Claude, or other tools. So large language models are AI systems that can understand natural language, meaning that when we ask it a question, it understands what we have asked. It is very good at reasoning, meaning that it can break down our questions into individual subtasks, look for answers, and provide us the feedback. It not just understands us, it also understands data, it also understands manual reports. So we can fine tune these large language models to understand a particular subsystem. So if we are talking about maintenance subsystem, we can fine tune large language model to understand the maintenance subsystems. We can fine tune a large language model to understand the crewing subsystems and so forth. Now, as Carl had mentioned, these large language models are usually very expensive. They are very difficult to host. And since we are having a targeted approach, we can use something called a small language model. Sometimes we do not need all the capabilities of large language models. In order to understand the maintenance subsystem, we do not need necessarily a large language model. We can do with a small language model, which we can train or fine tune on our existing subsystems and host them locally so that our information does not leak into the public domain or these providers. So point one, large language models are very good at understanding natural language, both from the user, both from documents and databases. But it has a problem. The problem it has is that it knows stuff, but it cannot do stuff. If we move to the next slide. So in order to move from knowing to doing, that's where agentic systems comes in. So let's look at a simple example to understand this. So let's say a junior engineer asks, how do I schedule a crew change for a vessel X next week? So the LLM, having been fine-tuned on the crewing system, on the certification systems and other subsystems, can give you step-by-step instructions on what to do. It can tell you that check the availability in the crewing system, verify certification, update rosters, and send notification. It can list out the things that you need to do in order to achieve this particular objective. It cannot do this for you. Now, this is a mundane task. For this mundane task, an engineer manually has to log into the particular system, enter the necessary information, uh, click through the workflow and achieve the objective. Now, so for such mundane tasks, we can bring in agents that can complement large language models and provide it ability to do stuff. And it does that with something called as the React loop, meaning that it has the ability to break down a complex objective into subtasks. It does that through the support of a large or small language model. So having the same query, how do I schedule a crew change for vessel X? It can be broken out down into sub tasks such as check the crewing system, check the certification system, check the roster system, and so forth. Next, agents bring in ability for large language models to use tools. What we mean by tools is that the LLM systems can access the existing subsystems. It can access the existing crewing software or the database. And we also provide it with something called as skills. Regularly, as an individual, when we are working with these systems, we have a workflow that if we want to query a particular crewing system, what information are we looking for? What do we do with that information? Now, these workflows can be provided to an agent in simple language by an expert on how they usually work with a particular subsystem, and the agent can mimic that workflow. So in an agentic system, we have a large language model. We have tools that are applications or databases these large language models can access. And for each of these tools, we have various workflows or skills. What are the things that the agent can do with these? Once the agent has posted the necessary query to the large language model, the large language model will break it up into individual subqueries or subtasks, and it will reason. So LLMs are very good at reasoning. It can reason that which subsystems do I need to access in order to fulfill this particular subtask or objective. Then it will use a particular tool to access that particular subsystem or database, query that database, and it will follow a predefined workflow using which it will retrieve the necessary information and combine that information to give you a concrete answer or perform a specific task like updating the roster. And that's the augmentation of doing to knowing via agentic system to LLMs. If we go to the next slide, I have a few minutes remaining. Carl?
Next slide. Yeah, carry on. That's fine. Yeah.
if we move, yeah. So in order to achieve this, what we are proposing is a lightweight knowledge intelligence layer. So when we are addressing bridging data silos, we do not want to create a redundant data store. That is the proposal, because the key issue is reduction of complexity and redundant. So we do not want to create a data lake where we pull in all the information and put it out there. Instead, we propose this knowledge intelligence graph that has pointers to existing live databases, live softwares, live tools. It also has within it metadata information on various available workflows that needs to be executed within a particular subsystem. And it can be very easily integrated to provide an integrated operation. So this would be a proposed soft integration within the existing infrastructure. And within this soft integration, it has pointers to existing subsystems and databases, including artifacts to know what to do within that particular subsystem. So when an agent queries a particular subsystem, it will look at the knowledge intelligence graph. It knows which subsystem it has access to and what to do for each of those subsystems. If we move to the next slide. So a practical example which I could think of is that, let's say there is a user which asks a simple question about maintenance due before voyage that affects emission and crew certifications. So the agent would break this up into individual tasks, check maintenance records, check emission databases, check certifications, and so forth. It will then go into the knowledge intelligence graph, look at the relevant applications that it needs to access, consume a particular or determine the tool that it needs to access those particular systems and databases, consume a particular workflow or skill to access that databases, and pull in relevant data to provide the necessary information or update or perform a task. If we go to the next slide. To conclude, so the point-to-point integration is a complex process. Agentic systems can reduce point-to-point connections by automatically discovering existing systems. If new updates are pushed to a particular software or a particular system, it can detect that, inform the human in the loop about the changes, and get integrated. It can reduce daily friction between crews and staff. We do not need multiple login screens, multiple dashboards. We can have a single interface that allows us to have an overall picture. And decisions, since we integrate multiple systems together, decisions can be made on an up-to-date picture. Next slide, please. So a few things to remember. We are not going to replace existing software or existing tools. We are proposing a soft integration. The existing softwares remain as they are. We augment that with AI and agentic connectors rather than manual connectors, and human oversight and configuration is essential. So the engineer or the crew who is performing a workflow needs to confirm the outputs presented by the agentic system. What the agentic system will do is reduce manual, repetitive, tedious work so that you can focus on things that really matter and leave the tedious, complex, and repetitive stuff to the agentic systems. So that's all I have. The last is the concluding slide, and I give it back to Carl.
Oh, well, thank you very much. Hopefully that's where we're going. That's a very interesting direction. So now I think we're going to Athens. Dimitri, your shirt and button is done up. You're going to explain about how we can work with the user interfaces. So I'll pass to Dimitri, cheers. Oh, you're on mute. You're still on mute. Oh, you click the microphone button and come on mute. You're on mute.
Hi, thanks for having me, Carl, and thanks for the audience for turning up to listen to us. I'm not going to give you a slideshow because what I'll be describing is more or less a product that exists. So I don't want to be commandeering this webinar with something that belongs to a single company. I want to talk you through some of the thinking and some of the decisions that were made some a long time ago as to what we're trying to achieve. To begin with, I'd like to say that I suggest strongly to anybody that's involved in neuro AI, LLMs, whatever you want to call it, that they get involved in the parts that they really care about, because there is a danger of getting involved in something that you've never done before. That includes people working in the office and having agentic AI available to them. It's best to use it where you really focusing, and that is, I think, the best advice from my experience I can provide. My fixation, as Carl knows very well, is that is situational awareness and introducing common sense into software systems. We've been building software systems for 30 years. And the parts that we always wanted to emphasize were the parts that made the software easier to understand. 30 years ago, we introduced task orientation so that everything you need to finish a task, some of which Antorweep mentioned, exists in one screen. So if you want to do some maintenance on a ship, and that maintenance is connected to environmental or reliability-based issues, you will be able to see what those are, defects and so on, that led to the need to do the maintenance. Certification, risk assessments, all those things would be in one place. So 30 years ago, we introduced a screen that combines the things you need to do from different systems, including whether your crew is certified to do the job, or if you have somebody on board that is. This concept has carried through. We're strong believers, and now with the introduction of neuro AI or language models, we attack the same problem using new tools. The concept of we've always introduced a model. I mentioned tasks before. We grew into a model of what the entire business does. Now you ask yourself, why do you need a model of the enterprise if you already got your ERP? The answer to that is Antorweep mentioned some of that, and that is that the ERP specializes, whereas a model of the enterprise doesn't specialize in one area or another. It can join them up. It's also an integration tool. So it also, one of the elephants in the room is also email. Most marine companies use email to inform themselves of what's changed that day. That is a very big part of situational awareness. What's your email say? And so what we have is a model of the enterprise, and the emails go and attach themselves to the right part of that model, or you can look for the emails individually according to nodes in that model. For example, what's happened to the parts that we expected to receive in this port? Did we receive them? Are they on board, and so on? It could be, are they the parts that we need for the next vetting inspection? Are they the parts needed for an urgent overhaul? So the system, as 30 years ago we had task orientation, has a model of the enterprise, so that everything that you say or do or mention in a document can be indexed to that model, and it can and is indexed to that model. Now, what is the role of neuro AI in all of this? Well, neuro AI understands spoken language. So it's not the only way to understand what's on an email and index it, but it's one of the ways, and it's a very comprehensive way if you use it right. So the Neuro AI understands what you're saying, and it understands the model that we put in there. So it can match what you're saying and what an email says or what you ask to that model of the enterprise. That creates a very structured way to look at unstructured information like emails. But it doesn't only do that, it also finds events and information that you need out of an ERP, like what is the latest defects and what do they have to do with a vetting. Do you have, vetting issues are huge in shipping these days. So you get an observation, it's related to something that you actually do quite regularly. Though what you do quite regularly, including how you train up for it, is relevant to your response to the vetting. It's also relevant to your preparation before vetting. So anything that you've got that's happening in the enterprise is covered by the model as far as we can manage that, because it's a big model. And then the information that comes in is indexed against that. Now, where does my focus again is the situational awareness. I think I'm not sure if I explained that well, but that's the part I just explained. The other is the common sense. LLMs don't understand how your ERP system works. You can break it down and you can go into detail and you can use various protocols to help you do that. But actually, the ERP system doesn't deal with processes. That's why you hear the word workflows. Your grandmother probably never mentioned anything about workflows when they wanted you to clean the house. So she didn't talk about workflow. The reason why you hear about workflow is because the rest of there is no other way to emulate the process in an ERP system. And workflow is very specific. It's not very general. You can't generalize a workflow. So if you say that I just want to send this to the ship, the workflow for sending it to the ship is very specific, but the actual intent that you have, and you may have that intent with a different process to what's in the workflow, it doesn't understand that. So ERP systems don't understand processes. They understand workflows wherever they exist. And that just is a sequential step. It doesn't abstract. You can't tell me what the workflow does. It's not easy, because the workflow just goes from one stage to the next based on conditions, and that's not an easy discussion to have. So common sense is the core, I believe, of the merger of a model of the enterprise with LLMs. LLMs understand spoken language and small language models as well. And I'm just using LLMs so I don't have to introduce a new abbreviation here. Any kind of language model will understand what you're saying, and it will be able to manage and vectorize a model of the enterprise. And that creates a huge step forward in the concept of understanding your applications, because it means that there is a structure of your applications which doesn't exist in your ERP, and there is a language model to talk to that structure. So the concepts that I find extremely interesting in the use of LLMs is the natural language capability. There's another capability that I'm interested in, but it's not necessarily timely for me to discuss or particularly easy to explain. But there's the LLMs abstract information. They use the same words, 3,000-4,000 words that we use regularly. And that means that everything that you say could be taken at a level of abstraction that's higher and generalized, which means that your ability to communicate with your ERP starting from an abstraction is much higher than if you have to hit the functionality of your ERP exactly where, the way that it's set up in your ERP. So in other words, abstraction and the use of LLMs are first cousins. So the LLM understands abstractions. It will find the area where you want to go, and and from there you can go precisely to where you want to go. This is why people are saying it's the new user interface. It is the new user interface, but it's not the new user interface only because you speak to it. Because if you speak to it and you expect it to go directly to a very small part of the functionality of your ERP, or a very small part of your documents and emails, it might not get there. It might make a mistake. Whereas if it can abstract and it knows the general idea, it's going to go and do that again and find you precisely what you want. So my message is that that LLMs have brought abstraction and common sense to the enterprise and to software, and it wasn't there before. Abstraction and common sense just weren't there. You couldn't compare two processes easily at all. You can't compare two workflows. So it was a very difficult slog. My emphasis is again situational awareness, and you have to build a model for that. It's not a model it's not a small model, it's a big model, but it works for everybody in the same industry. If you've got an LPG, or if you've got an LNG, or if you've got a sheet carrier, a lot of the processes are the same. Some of them are different, and you label them under contextually different things. So I'd like to finish this with my suggestion is that whatever you do with LLMs, it's something that you really know. In other words, you really know the area, you really know what value you're getting, and you embark on the steps that you want to take and the effort you want to make. And you bear in mind that the tremendous strength of an LLM, it's its ability to understand language. And if you give it a good model to interact with, it will be a huge help in the way that you use your systems, including integration, because a model will join up all the necessary points. A model will, in a maintenance environment, a model will join all the things that are needed in maintenance. That's what the model does. And situational awareness is achieved by the model because each thing that you read or that somebody tells you about, like we just received the spares or we didn't receive the spares, has a direct effect on other processes. It's not isolated. It's not by itself there. And this is the value of a model, which you're not going to get very easily. And therefore, I am very much in favor of what Antorweep said, that if you don't have a model and you want to join things up, there is a way to do that using language models, which previously wasn't there. Thank you very much.
Oh, very good. Okay, so we're open to questions now. Antorweep, I'd like to invite you to put your camera and microphone on. Firstly, did you want to respond to anything Dimitri was saying? So my own theory is that what Dimitri calls an abstraction model is what you call a knowledge and intelligence layer. You've both kind of come to the same conclusion, even though you're working in very different directions or looking at it in different ways, but you came up with roughly the same answer. This thing somehow has to sit in the middle, and one of the key things it does is it translates between the sort of factual world of traditional IT systems with the processes world of how people actually work and what they actually need to do. I don't know if that's how you see it, Antorweep. Do you?
No, I concur. He mentioned very right that these models, so these LLMs, do not know processes, and that's why we need workflows. And you are absolutely right that workflows are sequential steps. So it's a piece of paper. An expert will write that if I am working with a maintenance system, I will do this, I will do that, and I will do that. You will have n number of workflows. So while we are trying to address the data silo problem, we are creating additional artifacts, which are the workflows that in time may turn into another silo, which we do not know as of now. And that's where we are talking about this knowledge intelligence graph. So one thing is connection to systems, but we are creating new artifacts in order to interact with these systems. So in order to avoid that, we are proposing this knowledge intelligence graph that perhaps if implemented the right way could move in the right direction. So I concur, and we need to, so if we do not need to integrate LLMs or agentic systems to a particular problem, we don't need to integrate them. Just because it is the buzz, it needs to be done. It is necessary when you need it, when things are very mundane, when you have to do the same repetitive task over and over again. You can integrate AI system. If you are having planned maintenance, you can have other AI systems to help you forecast or predict when you do need the maintenance of certain sensors or certain devices and so forth. Yes.
Oh, very good. We've got a question here. So Anchor Mittal, I looked up on LinkedIn. I can see a Captain Anchor Mittal, Marine Manager, vetting and marine operations at D'Amico Society di Navigazione in Mumbai. He's asking, what if the legacy ERP does not have or is not willing to provide an API? I suppose that's quite easy to answer. You can't do anything. Is it?
I can just come in there. So that is again a contractual issue. So if they are not providing an API, agentic systems can look at the manual and see how a human would interact with that ERP system. So it can interact in that way. But again, it is a contractual issue. So is it allowed for the software or agent to interact with that system as a human or mimic an human?
Oh.
And I answer also that you do have access to the data schemas. So, and I think that if you're going to use agentic AI, you'll have to be able to access the data schemas, which you can because they're open. So you will be able to piece it together even without an API. Also, integration. Mentioning integration. Integration is not just one point to another. It's also how did you get that point? To get to a point in let's say that gives you an account code, let's say in one system matching to an account code in another, there's a whole thing, a whole world that translates all the expenses in a company to an account code and then translates it to another account code, which also has a world of processes behind it. So the integration is about going back into the source of the information and making sure that the information that you're actually integrating with has been derived in the way that you thought it was. It's no use just having a window, a box where an API that tells you here's my account codes. It's what went into the account codes that matters. So integration is a major issue, and it should be built into every application in order so that the kind of things we're talking about here can be done, like a user interface that does understand all the things you need to do to get something done, and something that explains to you what the workflow steps are. So integration is a huge part of what we should be discussing here. I just wanted to also add that the world model that or whatever model however you'd like to say, is not going to be the same. There's different ways of modeling. There's a model that you can do from a knowledge graph or from artifacts or and that's a very, very expedient way to get something done quickly. And there's a model of the enterprise, which is not so easy to do, but today LLMs can help you do that as well. So modeling is here to stay. There are various ways of modeling, and depending on the size of your task, for us, it wouldn't make any sense to use a conceptual model because we're not going to piece together what 18,000 processes are doing anytime soon. So we need to deal with 18,000 processes because that's what we do. But if we wanted to solve one problem, which would be let's integrate all our performance monitoring systems so that the data goes in one place and we don't have to worry how each ship or even the same ship can report performance to different systems. So if you wanted to join that up, there's a much quicker ways to do that than building a model of the enterprise.
We're sort of jumping between talking about a fact-based world and talking about a processes-based world, aren't they? Because they're they're very, very different, aren't they? And probably need to be treated quite separately. In the fact-based world is this object, this emission report, whereas the processes-based world is what do I do now? What am I going to change? Do I need to go faster or slower? Isn't it? I suppose it's maybe we need to separate these more carefully, do we, so people know what we're talking about?
The fact-based world is what a lot of ERP systems do, and you have to piece together the process that holds them together. We used to do that with task orientation, we still do, and you can do it with a model whereby all the steps that are factual and artifact based, like this is a purchase order, this is a delivery note, this is the transport bill. You can put those together in a view that tells you exactly what you want to know, what's going to be received on the shipment, what are the tools for it. But in the end of the day, we never worked with just facts. The processes are in our heads. It's just that now we want to coordinate people. We want people to be on the same page. We don't want one person to think that delivery is this, and the other person to say, well, sorry, you don't have the purchase order there, so how do you know it's that? We delivered that. We delivered it in a crate. It has 4 purchase orders. How do we know which one is covered? So we always worked with process. It was just the software industry has to fight to bring its methods into the reality of things, and it's mostly covering facts, as you say. So when you use a knowledge graph, you'll find the facts, but you won't necessarily find what strings them together. In fact, you won't. You'll have to guess what that is, which is not a big guess, but it still has to be guessed. So it makes the system awkward.
Well, so Antorweep, I don't know how this seems like a very complicated discussion. I know when we met, we talked about this example of a production engineer who always, when we were talking about petroleum, who always changes a choke on a well when something happens. So this is the kind of things that happen in the real world, that people always do things when certain things happen, which is very different to the world described in computer systems. But with these exploratory agents and knowledge intelligence graphs, you can capture the way people actually do work, which is much more than just the facts, isn't it? Is that
So yeah, I agree with Dimitris mentioned. So the knowledge intelligence graph captures the facts, or it points to the facts whichever where they are laid over. Now you need to remember, when we talk about agents, we are providing LLMs capabilities to do stuff. That's what agent does with its various facets. What are LLMs for? So you rightly pointed out earlier that LLM understands natural language both ways, from documents and from humans. In addition to that, it is good at reasoning. So if you give it a complex question, it can reason what I need to do to answer this particular complex question, what information I need to access. Then we go one level above this. How does it reason? And that's where what you call as processes-based knowledge comes in, which is not there in the knowledge intelligence graph. So when we take these LLMs or small language models, we need to fine-tune them so that they are able to improve their reasoning capabilities within our subsystem. We don't want them to, so it knows how to read our subsystems. It can read the manual, it can read the emails, documents that it already knows inherently. But we want to develop its reasoning capabilities for that particular subdomain. So how does it develop it? Well, you have an engineer, you have a staff who has been working in your company for the last 20 years. They intuitively know stuff. Like they see certain dashboards, they know that, okay, these 2 things are happening, I need to do this. They intuitively know that. It's in their head, as Dimitris mentioned. But there are paper trails for it. So when it does stuff, it is logged somewhere. Those are paper trails, right? When he sends an email to his colleagues, hey, I saw this and I did this. Those are paper trails, although not formally documented somewhere. Now, when we fine-tune these LLMs, we will try to fine-tune it on these actions, that experience actions that are recorded somewhere. And we tried, again, these are probabilistic. So these are not deterministic, but then again, intuition is probabilistic. So that's how we would try to build the reasoning capabilities. Now, these reasoning capabilities, when we build, there needs to be a human in the loop, because LLMs can reason in very creative ways. So the reasoning capabilities, once they are developed, a human in the loop or an expert needs to double check whether it is reasoning in the right way. If it is, then it gets embedded within the system. And when we are using agents, the agents will talk to the LLM. The LLM will reason certain things that, okay, I got these facts, and based on these facts and my internal reasoning, this is what I justify, or this is what I try to do. And when it says that, it gives that information back to the user. The user reads at the reasoning justification, why it thinks or suggests the things that it needs to do, and approves or disapproves it. So you have a double check, and that's where, yeah, the reasoning plays into action.
And I think when we met, you said so it's not literally reasoning, it's more mimicking a human's reasoning.
That's right. That's right. That's right. It's never pure reasoning. It tries to see the patterns which were hidden within the logs, emails, and so forth, and tries to match that. But we call that as reasoning. It's a subjective term. So
a typical maritime example: the engine makes a funny noise, and the chief engineer sends you an email, and somebody says this, and then this
yeah.
is what.
So there has been a chief engineer who knows that whenever he notices certain information in the dashboard, there is a noise reported somewhere, he knows what to do, right? So, and he does that. So when he does that, and these patterns have been recorded either as logs or as emails, then whenever a similar pattern appears, the LLMs will reason that I should do something similar.
Oh.
And when a new chief engineer comes who has not experienced this before, the LLM can suggest that, okay, in the past, whenever these things happen, we did this and it tried to solve. Then the new chief engineer can say that, okay, let's proceed in this direction.
Dimitri, anything you want to add?
Anything
you want to add?
Yeah, I think that this what we're describing here is quite a bit of work, and actually breaking down the business into what it actually does is a very important part of it. If you want to find out what somebody did about when he heard a noise, you've got to go into the right part of the system to figure that out. Reading 10,000 emails and to see if anybody said something isn't expedient. You have to narrow it down. So you have to have a structure or model of the enterprise where they do talk about these things. So I don't think that we mentioned anything here that can be done in a day. So I think we mentioned what potential there is. And I think when people focus on their personal expertise and what they actually want to do and what they can't do with the current system, we'll get to a result very much more quickly. We are open to that, and of course we can host agents that look, for example, you get an email string about notice of readiness. There's a subject we like to talk about, you and I, Carl, and it's a ship might miss its cancelling. There could be a lot of reasons for that, and there are a lot of things that can delay a ship. I mean, maybe 50 different things that can delay a ship. That you need to be able to focus on each of those and then dig up the information from there and get it in a story. What's going to put that in a story? When it's not necessarily, there's three or four different departments involved in the cancelling of the ship. So that you need a structure there to gather the information, and then you need the LLM to reason for you if there is an issue of reasoning, because a lot of the time your problem is a little bit beyond your ability to reason it out. But you do need a structure in order to get the information to provide to the LLM, and the LLM then is able to make suggestions.
Wow, good. Go on.
Just add to that. So there are two parts to it. One is your integration problem, and another is the reasoning problem. Now, the reasoning problem is a hard problem. It cannot be done in a day, and it needs to be proven in research that we are trying to reason in the right way. But the integration problem itself, so there the LLMs doesn't need to be fine-tuned much, because the data and the systems, they have manuals, they have schemas. So it can learn the unique schema of a Postgre database, of a SharePoint database, and another document management system. So these are standard in their own way. So the LLMs would understand how to access a particular system and database based on the manuals, artifacts, and schemas that are available. And then it can reason on which databases and systems to query in order to answer a particular question. So the integration part or the soft integration part is an engineering problem, and that can be something that can be done. The reasoning, developing advanced reasoning for a particular sector is a research question that needs to be addressed in a different direction.
Oh, very good. We've got about 3 minutes left. Maybe if you both want to share thoughts about how we move forward. And there's also another question coming here from Ofi Eginosa. How can agentic maritime systems support human decision making under stress? But so, I mean, Antorweep, so you mentioned, so you're an academic, so these are academic ideas, but obviously a lot of great technologies were academic ideas before they became commercial technologies. So, but it's also, I suppose people have to be ready for a long haul here. We all get impressed with large language models doing great things right now, but these things are going to take a while to build. But also, I think you're opening the university to companies sponsoring you to put PhDs to work on projects like this, that kind of thing. I don't know if either you'd like to leave a couple of closing remarks about how we go forward and perhaps answer Ofi's question while you're in it.
Sorry, I didn't get the question, but under stress,
Oh,
how does agentic system help? I think
well,
if that,
decision making under stress on ships.
well, decision making under stress. So first thing is that in order to address any decision making, we need to have a complete picture. Integrated systems, whether offered by agentic systems or traditional integration, could offer you a complete view. Now, when you are using technology, whether it's AI-based technology or any other software, you are making a decision. That decision that is recommended by the system needs to be justified. So if that justification is provided to you, irrespective of what platform or technologies you use, you can trust that to make a decision under stress or distress. All right.
Yeah.
Now, the parting thought is this, that I think using agentic systems as an engineering problem for integration, we are ready for it. But you will not able to enjoy the full flavor of it unless pure reasoning is integrated or applied. Having reasoning capabilities, enhanced reasoning capabilities within the Maritime's ecosystem will take time, maybe 1 year, maybe 5 years. But I think we should start with agentic soft integration. It is an engineering problem and it can reduce mundane repetitive tasks.
Oh, closing thoughts, Dimitri?
Well, I'm a great believer in situational awareness. I don't think people are immediately need help with decisions. I think they really need help finding what other people are saying and coordinating the enterprise. So being a practitioner, I'm biased towards situational awareness and what's going on. And then we move to the reasoning and the decision making. About the question about will an LLM help or will AI help make a decision under stress? Well, decisions under stress are normally shared with other people on the bridge. If somebody's got a decision to make, it's standard practice to communicate what it is you're trying to do or what the problem is in order for other people to intervene. We've seen accidents with two people in a small plane, all talking about the same thing and not paying attention to what's going on outside. That's the trick is to know what's going on outside. An LLM will help you if it knows exactly what situation you're in. But if you hasn't got the data, because it doesn't know, let's say you ask it, what do I do with this? Do I stop the engine? Do I take the piston out and go with 6 instead of 7? It won't know that unless it knows everything, but all the information that built up to the situation. So yes, you can use. I think that LLMs will give you a good assessment as long as you give it a lot of input and you've programmed it for that decision. There's a lot of decisions to make, so there's a lot of programming you'll need to do.
Oh, fantastic. Well, that's the end of the webinar. I think that's been a fantastic picture of where we may be going with maritime agentic AI systems, and I think there's a lot further to go. So thank you very much, Dimitri and Antorweep. We should have the video on YouTube very soon, and I'll pass back to Farah for the closing words. Cheers.
Thank you to Professor Antorweep Chakravorty, Dimitris Lyras, and to our audience. An email with a link to a recorded video of today's webinar, mentioned earlier on, will be sent to you soon. Do check our website for more of our future webinars, and we'll see you soon.
Bye-bye.
Bye.
Thank you very much. Thank you.
Bye-bye.